Hey there guys, here we're going through a couple more geometric sequences and series exam questions. Download them and this page is in there too, and let's go. Alright, first up, a competitor is running in a 20-kilometer race. She runs each of the first 4 kilometers at a steady pace of 6 minutes each, and then begins to slow down. To estimate finishing time, the time taken to run each subsequent kilometre is modelled as 5% greater than the previous kilometre. Using the model part A, show that the time to run the first 6 kilometres is 36 minutes 55 seconds. Alright. So, for the first 4, that's 4 times 6 minutes. So that's 24 minutes. Alright, now the 5th kilometre, well that's 5% greater, so that's 6 times 1.05. Now that is 6.3 minutes. And then the 6th kilometre, that's 5% greater than 6.3 minutes, so 6.3 times 1.05. Now that gives us 6.62 minutes. Alright, so let's now turn the decimals into seconds. So the total time so we got 24 add 6 add 6, so that's 36 minutes. Add 0.92 of a minute. So, multiply that by 60 and we get 55 seconds to the nearest second. So, we do indeed get 36 minutes. And 55 seconds. Okay then, part B, we want to show that time to run the earth kilometre from 5 to 20 is 6 times 1.05 to the r minus 4. Alright. So, we know the 5th kilometre was 6 times 1.05. Now we can think of that as 1.05 to the power of 1, or 5 minus 4. We then know the 6th. took 6 times 1.05 squared. Or to the 6 minus 4. So what we can see is the power on the 1.05 is 4 less than the kilometre number. So if we skip a few, and then the Earth kilometre is indeed 6 times 1.05 to the R minus 4. Alright, now part C wants us to estimate total time to finish the race. So, we know the total is the 24 minutes for the first 4 kilometers, and the time for the last 16 kilometers. So let's say add time for the last 16 kilometers. Alright, now let's think about those last 16 as a geometric sequence. So, alright, so the first kilometer, the first kilometer we care about is the 5th one. So that's 6.3 minutes. So that's the first term of our geometric sequence. And we know that R is 1.05. So, now we want the sum of 16 terms of this sequence. So we want the sum to 16 so that's 6.3 times 1 minus 1.05 to the 16 over 1 minus 1.05. Alright, now then, that gives us 149.04 minutes. Now that in minutes and seconds is 149 minutes. And 2 seconds. So the total time is 24 minutes and 149 minutes, 2 seconds, so that's 173 minutes. And 2 seconds. But to prove that there is no possible value of q such that 3e to the minus q 5 and 3e to the q are consecutive terms in a geometric sequence. Alright, so this is a job for proof by contradiction. So we're going to start by assuming there is a value of q such that these are 3 consecutive terms of a geometric sequence. Right, so now that we've made that assumption, we now work through the logic and try to find a problem or a contradiction. So if they are consecutive terms, then we could say, therefore, 3e to the minus q times r is 5, and 5 times r is 3e to the q. Alright, now we are interested in q. Now, to get rid of r, we can divide one equation by the other. So, I'm going to do the top one divided by the bottom one. So we're going to get 3e to the minus q over 5 is equal to 5 over 3e to the q. Alright, now if we multiply through by e to the q, that also cancels e to the minus q. So this is saying that 3/5 is equal to 5/3. Now that's obviously not true, so this is a contradiction. So we would now say, but this is a contradiction. So, what that means is when we've assumed they are consecutive terms in a geometric sequence, that means that 5/3 is equal to 3/5. So it's broken maths. Therefore, it cannot be true. So we then need to finish by saying, therefore, there is no value of q such that they are consecutive terms of a geometric sequence. Cool. And then guys, that's the end of that one. Really hope it's helped. Next up, we're looking at a mix of arithmetic and geometric sequences and series, specifically using summation notation. Hope to see you there. Take it easy. Take care.